Swayam Prabha, free DTH channel for education.
So now we are going to deal about the first order linear ODE. Okay, first order linear ODE, which we need to see what is it. So first we need to understand what is a linear means. Okay, so you might have studied this kind of things in the linear algebra course or somewhere. So that's a linear transformation. Means you have a vector space. Okay, you have a vector space V and another vector space W is there. Suppose T is a mapping from V to W. Okay, I call T as a linear transformation. If V is a vector space, means there should be a scalar. There will be a scalar for that. So in that case, what I'm going to define is that I'm going to define T of alpha. Two vectors you take it. Okay, take any two vectors U and V in V, then define T of alpha U plus beta of W. Okay, so now take the linear transformation for this expression. Okay, alpha U plus beta W, or okay, let me put beta V. Okay, alpha U plus beta V. Then you have to find what is alpha of T of U plus beta of T of V. Okay, so this expression should be valid. T of alpha U plus beta V should be equal to alpha into T of U plus beta into T of V. Then if it is valid, if this equation is valid, then we say that T is a linear transformation.
Following equation L of x comma y dash equal to 0. Okay, if L is linear, so generally whatever the equation y dash equal to f of x comma y, if I'm giving, then you can write this as in this form L of x comma y dash equal to 0. Okay, so if this L is linear, okay, L is linear, we already see what is linear in the last definition. So if L is linear with respect to, okay, both y and y dash, both variables y and y dash, then we say that it is linear, first order linear ODE. Okay, otherwise we say it is not if it is not linear with respect to at least one of the variable, then we say that it is a non-linear ODE. For example, you can take some of the I'm not saying like it is linear with respect to x, I'm just saying only with respect to y and y dash. For example, if I take like y plus y dash equal to x square. Okay, so it is not linear with respect to x, but I'm not saying it is not linear ODE, it is a first order linear ODE only. Whereas if I take this one, y dash equal to x square. Okay, so whether it is a linear or not linear, that I'm just leaving it to you to think of. Okay, similarly, if I say like y square plus y dash equal to x, and y plus y dash square equal to let's say 2x. So these are all I'm just leaving it to you for an exercise, like you can just say whether which one is linear, which one is not linear, etc. Okay, so let's go to the next one. Okay, so the first order linear ODE, how we can reformulate it. Okay, so that let us see. So the general form of the first order linear ODE, how it is going to be there. So the general form of the first order linear ODE is of this form. Okay, you can write the general form of the first order linear ODE in this form: a1 of x into y dash, or I write it as dy by dx, okay, plus a2 of x into y equal to b of x. I can write it in this form. Okay, so provided this a1 of x is not identically 0. Okay, it is not identically 0. If it is identically 0, what will happen? This is identically 0 means it is going to be 0. Therefore, it is going to become like simply a2x equal to y equal to bx. That means it is a normal equation. Okay, that there is no differentiation is there, so it is not going to be a ODE. It is simply a equation. Okay, it is simply a equation. You can say like even linear equation, etc. So if this is not there, okay, so this is if this is not equal to 0, identically not equal to 0, then we say that it's a first order linear ODE. Okay, so if the p of x in the right hand side, if the p of x is identically 0, okay, if it is 0, if it is identically 0, then we say that this is a homogeneous ODE. Okay, it is called homogeneous ODE. If it is not identically 0, okay, if it is not identically 0, then we say that it is a non-homogeneous ODE. Okay, so if the right hand side is the p of x is not equal to 0, okay, it's called a non-homogeneous ODE. So Okay, so in this equation, a1 of x is not identically 0. Therefore, I can divide that. So what I can write this as dy by dx plus a2 of x divided by a1 of x. Okay, since it is not identically 0, equal to p of x divided by a1 of x. I can write. Okay, so this is not identically 0. That's the reason I can just write it as a1 of x by a1 of x and divided by a1 of x here. So in this case, I can into y is that. So in this case, I can write this as dy by dx. Okay, I can rewrite this way plus p of x. Okay, so these all these terms I'm just calling it as p of x equal to, I'm just going to call it as r of x. Okay, here. So this is the general form of the, this is the linear ODE, first order linear ODE general form. Okay, the first order linear ODE general form is this way. Okay, so these are all first order ODEs only we are discussing. So that is the reason I'm just clicking.
We have the problem. Okay, x into dy by dx minus 3y equal to 0 is done. Okay, this is the problem given to you. Now what we need to find is that we need to solve this problem. Okay, so we can solve this problem. So assume that x not equal to 0. If x equal to 0, this is not going to be a linear ODE. It is going to be simply expression 3y equal to 0 and y equal to 0. You can easily find it. Okay, so one of the trivial answer for this one is that suppose I put y equal to 0. Okay, if I put y equal to 0, it's going to be satisfied. If I put y equal to 0, this is going to be satisfied. Okay, that is definitely it is going to be the solution for that. But what we want is we want a non-trivial solution. Okay, for non-trivial solution, we assume that x is not equal to 0 and y is not equal to 0. Okay, so in that case, what I can define, since x is not equal to 0 and y is not equal to 0, I can define this as dy by dx minus 3y by x equal to 0. I can define. Okay, or I can rewrite this equation as, I have to integrate this and I can rewrite this equation as dy by dx equal to 3y by x. Okay, and what I'm going to do now, okay, I can just bring this, I can rewrite this equation as dy by dx 1 by y. Okay, 1 by y, I can put it over here, equal to 3 by x. I can write it. Okay, you can write this expression provided x is not equal to 0 and y is not equal to 0. If x is equal to 0 or y equal to not equal to 0, you can't divide it because this is not going to be valid. Okay, this expression is not going to be valid. So in this case, what I have to do, now I have to go for integrating. So I'm going to integrate on both sides. So 1 by y dy by dx into dx equal to 3 by x into dx. So I'm going to integrate on both sides with respect to x. Okay, so I'm going to use this one, dx by x. Okay, now what does it mean? So dy by dx into dx is going to be there. Okay, this I can write it as, this is going to be, see, usually I don't know like how you have learned in the P-Tech level. So usually people used to think that this is a ratio. Dy by dx is not a ratio. Okay, it is an operator. D by dx is an operator. This operator is operating on some function. Okay, for example, y. That is nothing but the definition of this dy by dx. It is not like dy by dx is there. Okay, dy by dx is not a ratio. It is a operator, d by dx of y, and differentiating this variable with respect to x, that is the operator. It's not a ratio, that you should remember, because when I give this equation, people simply put that dy by dx equal to this one, so put dy by y here and put the dx over there. That's not the case. Okay, so dy by dx is, this is an operator. So I got to differentiate with respect to this one. So then I can write this one as, okay, 1 by y. This I can write as d of d by, this I can write as dy. Okay, d of y into dx by dx I can write as dy. Okay, d of y into dx by dx. So this is going to be with respect to x, I have to differentiate. So that is the reason we are going to get, this is antiderivative. Okay, if you just take that, this is going to be antiderivative. Okay. Okay, so now, so this is the one. Okay, dy by dx of dx, which is I can write as dy. Okay, this one I can write as dy. So that's what we are trying to do here. Okay, dy by dx of y, that is nothing but dy I can write. So therefore I can write this as dy by dy, and this is going to be 3 into dx by x I can write. Okay, now what is this one? This is going to be ln of mod y equal to 3 into ln of x plus some constant is going to come. Let's say some constant is going to come. Okay, so if I differentiate this one, you will get the same thing. So if I differentiate this one, you are going to get 1 by y, 1 by x c is going to cancel. Okay, 3 by x is going to come, so we are going to get the same thing. 1 by y divided by dx is going to be 3 by x plus c is going to come. Okay, so you should remember that you should define modulus of y. Okay, because ln is not defined on the negative. Okay, ln is not defined on the negative one. Therefore, you should be very careful. You should put the ln of mod y. Okay, ln of negative 0 or negative number is not defined, so you have to use this one. Fine. Now what we are going to do is that, so from this one, I'm just going to simplify this. Okay, this c, I am going to write this as 3 ln x plus some constant I can put. Let's say like ln c1. Okay, and this I can write as c1 into ln c1 into ln is going to come. Therefore, I can write this as ln of c1 into x cube. I can write it, and this side is also I have ln of y is there. Okay, so therefore, what you are going to get, take the y and take the e power on both sides. So therefore, you are going to get y equal to c x cube or c1 x cube is going to come. Okay, so that is going to be your solution. So you can see that y equal to c x cube is the solution to 15. You can just check that. If I just differentiate this one, you are going to get this one. For example, I can just check, verify that whether it is going to satisfy this one. So you can just take the differentiation of this one. So y dash is going to become like 3 c1 into x square is going to come. Okay, so if I multiply this on both sides, x into y dash is going to become like 3 into c1 into x cube is going to come. So x into y dash is going to be c1 x cube is nothing but y. So 3y is going to come. That's what we have. X into y dash is going to be 3y. Okay. So you can see the graph of that function also. When c is greater than 0, you have one curve, and c is less than 0, you have one curve. So we are not getting a unique one. We are going to get an infinite number of families of curves are going to come. Infinite families of curves are going to come. That's what we have here. Now we asked one question. Can we? So we asked this question, right? We asked what is the mathematical concept and what is the mathematical theorem behind this logic. Okay. For that, we are going to answer now. Okay. We are going to answer that. So that is nothing but the fundamental theorem of calculus. Okay. So that is called fundamental theorem of calculus. So what is it going to say? So in general, we need to solve this problem. Okay. What we need to solve is that in general, we need to solve the problem dy by dx. So in general, we need to solve this problem dy by dx plus p of x into y equal to r of x. This is the linear ODE, first order linear ODE that we need to solve. So we are going to take three case by case. Okay, first case number 1. What I am going to do is that case number 1 is nothing but I am going to assume p of x is 0. Okay, if p of x is 0, what is it going to come? Okay, assume that p of x is completely 0. Then what I am going to have? I am going to have dy by dx equal to r of x is going to come. Okay, this is first case. Case number 2. Okay, case number 2 is nothing but, so I have case number 2. Okay, case number 2 is I am going to take the r of x equal to 0, means I am going to take a homogeneous ODE. So in that case, this is going to become like, so r of x equal to 0. Okay, so in that case, I am going to take dy by dx plus p of x into y equal to 0 is going to come. So this is case number 2. Then case 3. Okay, case 3 I am going to consider everything. Okay, case 3, only in case 3 I am going to consider everything. Okay, so here I am going to consider dy by dx plus p of x into y equal to r of x is going to come. So in case 3 only I am going to take. Okay, so here p of x equal to 0, here r of x equal to 0, here p of x and r of x are not equal to 0, that we are going to get. Okay, but if we solve this problem, these are all going to be particular case that is going to come. Okay, now what we are going to do is that we are going to solve case 1. Okay, we are going to deal with case 1. So dy by dx equal to r of x is there. How do we solve the problem? So I have consider the simple case for case 1, which is nothing but p of x equal to 0. Then what is it coming? Dy by dx equal to r of x is going to come. How do we solve this problem? So already we have solved a similar kind of thing. So dy by dx equal to 5 e power 5x or dy by dx equal to cos x plus 2x. So there is no y involved in that. So there is no p of x. So p of x is completely 0. Therefore, you can solve this problem using the fundamental theorem of calculus that we are going to see. So what is the fundamental theorem of calculus? So suppose f is continuous. Okay, So fundamental theorem of calculus is going to say, so we have the mathematical concept that we have the curve. For this, we can find the area under the curve, which is nothing but the integral calculus. We can do that. Okay, that is the area under the curve used to find. Now, suppose f of x is given. Okay, if f is continuous, f is given, it is continuous. F is a continuous function. Okay, and is defined on an interval a comma b, close to interval a comma b. Okay, f is continuous on an interval a comma b. Then you define new function. Okay, then define capital F of x equal to integral a to x f of x f of t dt. Let me say. Okay, that means f is a continuous function. Let's have this continuous function. Then what I am going to take? Suppose I take x here. I am going to integrate. Okay, a to x. I am going to integrate this curve and then going to calculate what is the area under that curve. Okay, so that is nothing but we are going to calculate. Now this f of x, this theorem is asserting that this f is also continuous. Okay, this f is continuous. If this f is continuous, you take the integral, the area under the curve, that is also going to be continuous. Okay, on AB. Okay, and not only that, it is going to be differentiable. Okay, it is not only continuous, it is differentiable. Means you have f dash of s is also there. Okay, f dash is different, f is differentiable. Differentiable. Okay, so f is differentiable, or I can say that f is differentiable, or I say f dash exists. Okay, f dash exists. And differentiable on, I'm not going to say everywhere. Okay, I'm going to say except the boundary point, I'm going to say differentiable on a comma b. Okay, so that I have. Now what I have that I can calculate my f dash of x. Okay, what is the f dash of x is going to come? F dash of x is going to be d by dx of integral a to x f of t dt. So this is going to be f of x. Okay, so I can find the derivative. The derivative is going to be f of x. Okay, so f is, suppose f is any antiderivative, not only this one. Suppose f is any antiderivative, then what you are going to get is that you are going to get some on AB. Then what you are going to get is that you are going to get f is any antiderivative. Then what you are going to get is that you are going to get the second part of the fundamental theorem of calculus, which is going to say integral f of x dx. Okay, is going to be f of b minus f of e. Okay, so means you are going to calculate your f of b. Okay, you are going to get another equivalent function. Okay, so for that you are going to get this f is continuous. This is defined already. If you take the difference between those two, okay, so there is another function you have. Okay, you have another function f is there. For that you are going to calculate what is your so you define it somewhere. You define what is your a, f at a we find it. Okay, f at a and f at b we find it. Okay, and then calculate the difference between them. That is going to be your f of b minus f of b. Okay, so that is going to be like we have something like a and b here. You calculate what is your f of b here. Okay, and calculate this over here. Okay, then you calculate what is f of b minus f of b. That is going to give you the answer. Okay, so this is the theorem is asserting. So this you might have seen in your P.Tech level courses. So I'm not going to give the proof of that. Now we are going to deal this case. Okay, we are going to deal this case. So this is going to help us. Okay, so suppose I have a this is going to be help us. Okay, suppose my r of x is continuous. Suppose I have dy by dx equal to r of x is given. For this problem, suppose my r of x is continuous. Okay, r of x is continuous, and all the conditions of this theorem are satisfied. So in that case, what I can do is that I can just find what is the solution for this problem. I can suppose r of x is continuous. Okay, by the fundamental theorem of calculus, what you can do is that you can find r of x equal to integral. Okay, some x naught to x I am going to put. Okay, some initial point is given x naught to x into r of x dx I can find. Okay, I can find that. Then what is it going to become by the fundamental theorem of calculus? Your r dash of x is going to become like r of x. Okay, your r dash of x is going to become like r of x. Therefore, if I substitute over here, okay, if I substitute y equal to r of x, then I am going to get y dash is nothing but r of x, r dash of x, which is nothing but r of x. Therefore, this is satisfied. Okay. So here R of x denotes the antiderivative of small capital R of x denotes the antiderivative of small r of x. Now the question is, do you have a single R of x or do you have multiple R of x? Okay, is there any other antiderivative that satisfies this equation? That also we can check. Okay, so in general, if I put y equal to, so instead of R of x, if I put y equal to R of x plus c, okay, if I put R of x plus c, then this is also going to satisfy because my y dash is going to be R dash of x. Since c is constant, that is going to be 0, so that is also going to be satisfied. So if you take any antiderivative, okay, suppose you have any other antiderivative, if you take, suppose say s is another antiderivative, okay, s is another antiderivative for this R of x, okay, that solves this problem, then s is going to take the form, okay, s of x is going to take the form, R of x plus c is going to be there. If you take any antiderivative, that is going to satisfy this form, okay, for some constant c. Okay, so now, so this is the existence one. Now for uniqueness, what we need one more condition. Okay, suppose dy by dx is given. Along with that, I have the condition y of x not equal to y naught is given. Okay, y of x not equal to y naught is given. So in that case, what I can do is that I can define. Okay, I can define my uniqueness of this one. Okay, how do we define the uniqueness of this one? So suppose y of x not equal to y naught is given. So in that case, what I can given? Okay, y of x equal to y equal to R of x plus c is given. So this is going to be general solution, or existence is going to be there. Now what I am going to see, I am going to satisfy that condition. Therefore, if I substitute that, y of x naught is going to become, okay, y of x naught is going to become like R of x naught plus c is going to come. But what is R of x naught? R of x is nothing but x naught to x. Okay, wherever x is there, I have to put x naught in this one. So this is going to be R of x into dx. Okay, the limit I got to put it is x naught to x, instead it is going to be x naught to x naught plus c. But what is x naught to x naught? This is going to be 0 because I don't have any interval, therefore this is going to become 0, therefore only c is going to come. Therefore c is going to become like y of x naught. So in that case, the solution is going to be y is going to be R of x plus y naught is going to come. So r I can write it as, you can write this as y naught plus integral x naught to x R of x dx is going to be your solution for the problem. Okay, your y of x is going to be of the form y naught plus x naught to x R of x dx is going to be your solution for this problem. Case 1, dy by dx equal to R of x.